Alright, hello. I am Chris McDonald. I'm the science specialist here at Learning Commons. So make sure you can actually see me so you can, initially, so you can see who is talking at you with this boot camp. I want to welcome you to Chem 1045 boot camp for fall 2020. Hopefully you'll be able to take advantage of our services at the Learning Commons during the semester, and that I'll be able to see you, hear from you, and work with you. The way I'm going to do this boot camp is I'm going to start off first half or so. I'm going to go over what the Learning Commons is, what we do, and so on. Just kind of doing a little bit of advertisement. Well, not really advertisement, more of informational, and then moving into some content related to Chemistry 1045. Alright, and I will have my contact info up, so you can always email me with questions, okay, or just get in touch. Alright, let me turn off my webcam here so you can actually see the screen. Let's get this slideshow going. Whoops, I have it in the wrong screen. So, hold on. Okay, here we go. I got it fixed. Alright, so Chem 1045 Bootcamp, Fall 2020. Alright, I don't know why that first part skips. I keep forgetting to fix that. So, at the Learning Commons, we kind of split our services technically into communications and then math/science. This is based off of our physical spaces that we work with at the Learning Commons. We have downstairs on the first floor, we have math and science, and then upstairs we have communications. Although we have moved biological sciences into a room that is upstairs with the anatomy and physiology model. So it's a pretty nice room, so I would encourage you, if you're on campus, to check it out. Okay, we're fully open. Our physical location, brick and mortar, quote unquote, is fully open on campus, so you can visit us in person or online. I'm going to go over how to access us online. We're always going to have a tutor available during working hours to help you out with whatever. Alright? Some of this I'm going to be talking about the virtual space, some of it I'm going to be talking about the physical space, kind of switching back and forth, okay? And some of this, there is crossover. Open access computers, that's physical space. You come in, we have computers that we have deactivated every other computer in rows and set up at least 6 foot spacing between different computers. So, if you don't bring your laptop or need access to a computer, we do have access to those here on campus in Learning Commons. Okay? Can't promise you how fast the computer will go, but they are available. Okay, not that they're super slow, but I'm just saying that we don't have all the top of the line 2020, well, I should say 2019 computers. 2020 has become a like a bad word almost. So we've got tech support. That's any of the tutors, specialists here can help out with a lot of basic access issues for Canvas or some of your online platforms that you're working with. In chemistry, you're going to be working a lot with Lumen Ohm, and so we can help you out with a lot of that. That's going to be actually a big part of the early part of the semester. It's just figuring out how to do your Lumen Ohm homework. There's little things that you have to do format-wise and kind of figuring out how to operate different parts of it. It's not a big deal. You just got to kind of get used to it. Okay? So the beginning part of the semester, both in content and technology-wise, kind of is helping prepare you for the rest of the semester. Alright? We put on workshops. So like communications is going to put on reading and writing workshops, different grammar workshops, and then math and science, we have a lot of exam reviews. We're going to put on technology workshops, especially early in the semester, to help get you familiar with the technology that's available and get you comfortable with it. And then online, resource guides and handouts, we have all these handouts and resource guides in our physical environment and online in what's called the virtual learning commons. We're switching over to a medium, slightly different medium that we think will be better for this current online environment, kind of transitioning from that virtual learning commons to something that we're calling learning commons online. It is under construction, should hopefully be finished sometime during the semester, but at least for the time being, we do have a reservoir, both physically and virtually, for these resource guides and handouts. Okay, and I'm going to show you the link for that. I'm going to show you how to access that in a little bit. Of course, content tutoring. This is like a big thing that we do. We have full-time staff who are here who are specialists in each of their fields. I'm a science specialist. I take care of chemistry and physics, biology, earth science, environmental science, anatomy and physiology, microbiology, any of that, okay, is what I cover. And then with math, any of your math courses from, the like introduction to college math and intermediate algebra all the way up to calculus 3. And then we do coverage for different English and communications, writing type classes, and especially with communications, they cover a lot of different classes. You're going to see if you're in something like POS 1041, which is National Government, or AMH 2020, or PSY 2012, you're going to be doing a lot of papers and reading and writing, and so they can often help out with a lot of that. We have Spanish tutoring as well. So we cover a lot, if not all, areas. We've also got finance and economics, accounting tutor who comes in. He's got the most limited hours of anybody. So if that's something that applies to you, you're going to have to figure out when he's around. Okay? We are here for you. We want to be available for you. We want to make sure that you can maximize usage of our resources, both virtually and physically. Okay? Our normal hours of operation are 7:30 to 7:30 Monday through Thursday, and then 7:30 to 5 p.m. on Fridays. Okay, so this is when you can come in physically or catch us in the virtual environment. So specifically in the math and science area, we can provide assistance with math, science, economics, accounting, and then technology. All right. I'm going to be taking care of anything science related, and then we have a bunch of tutors who have taken the classes, who are very good at it, and honestly have been tutoring this for a long time and are really good at it. So I really recommend that you take advantage of them as resources. Okay, repeating about the handouts and worksheets, we practice worksheets, interactive online activities, and then the workshops. I think I skipped over what I'm going to be doing workshop-wise, which is a lot of exam reviews. Okay, some of the chemistry teachers, they like to say that they schedule their exams organically. Okay, that they just kind of go with the flow. What that means is that they don't have exam dates stated in their syllabus. Okay, so I'm going to try to keep track of that, either through them or through you or both, and I'm going to try to schedule exam reviews that cover as many classes, if not all of them, around the time that your exams are, because there are common times, but sometimes some teachers schedule an exam like a week before, others are a week after. Okay, so but I'm going to try to maximize how relevant my exam reviews are. I would like to state that these are reviews. Really, the best thing for you to do is going to be to talk to your teacher, go to your teacher's office hours, and to try to get more active tutoring from us before review. Okay, try to not be learning something during a review. It's fine if you are. I know it's a lot of material, but the more consistent you are, the better. In the physical environment, I have anatomy and physiology models and then chemistry models that you can access, check out. I just have to wipe them down before and afterwards and use gloves. Okay, the chemistry models are in my office, and then the anatomy and physiology models are upstairs. I have a whole procedure up there. Okay, so staff in the math science area can provide students with one-on-one conferences in math, science, accounting, economics, up to 30 minutes. Okay, this doesn't mean that you get 30 minutes. Okay, it might be that the best thing is for you to come in and you briefly have like a 5-minute session or something like that, and the tutor tells you, hey, actually, I want you to bring up your notes, I want you to look into this, I want you to try this problem, and we'll check in again a little bit later, something like that. Okay, so it doesn't have to be 30 minutes. With this online environment, especially with the first time that you come in to get tutoring, we very easily will push that time, okay, because it takes a little bit of time to get used to the platform, to sign in, to get connected, and just understand how to interact, okay? So, you know, kind of on one hand, we're saying that the session doesn't have to be 30 minutes. You know, you can't come in and just demand 30 minutes. But on the other hand, we're also saying that we're not going to limit ourselves. We're not going to just look like, oh, okay, it's 30 minutes, time up, like halfway through or 3/4 away working through something. Okay, so you know, it's up to each individual tutor, but this is really what we try to set. There's really, the longer that you have a tutoring session, even the less effective it becomes. That might kind of, you're like, well, how does that work? Because we want you to we want to make sure that you are independent learners, that you can figure things out on your own. Sometimes we might not even go over content with you. We might just go over study strategies and different ways to approach the material and tell you what's something that you need to do, and then you come back later. Okay? But you know, we all care. We want to try to come up with the best solution for you. Now, it doesn't have to just be one-on-one tutoring. You can come in and you can come in with a group, either physically or online, and you can work with a tutor or multiple tutors depending on what the demand is at that time. Okay, so keep that in mind. You can do one-on-one, but also we can do groups. Okay. What we won't do is we're not going to directly help you on take-home quizzes and tests, especially with specific problems, okay? We might be able to tell you an approach for how to go about doing that take-home quiz or test, but we're not going to work on a specific problem, okay? If you have something that's just written on a piece of paper, we don't know where that came from. Very easily could be a quiz or test, and so we want to see the actual source. Okay. Sorry, I don't know if you can hear the beeping, but people are emailing me a bunch right now. So, I told you we have the virtual learning commons. This is where we have our resources right now. We're eventually going to move it to something called Learning Commons Online, but we at least have it available online in this format. Okay? So, I mean, you can see using that link you can get directly here. But I want to show you from the home page, a pathway to get here. There are multiple different pathways to get here. Okay? Easiest thing is always just use the search function. Okay? So, oh no, I don't know why it's doing this. It does this to me sometimes. Come on. There we go. Okay. So, even if I just put in Learning Commons is the first thing that comes up, okay? And so, What I was talking about is the resources. We have two other links right here. So I'm going to show you the resources, but then I want to come back and show you these other two links too. Resources, I clicked on resources. We actually have multiple options here, but you're going to want to click on Learning Commons Virtual Resources, and then you can either search or you can go into one of the relevant sections. Honestly, you go into those, it's going to do the same thing as if you just search. So we put in chemistry, brings up all of our chemistry resources. Alright, now what we're trying to do is we're trying to get a little more integrated source for all of our materials and everything Learning Commons related, but this is the way to get to the resources right now in virtual environment. We have our success coaching. We have Sam Deserga. She's awesome. She does a lot of success coaching, working with you to figure out different skills and strategies to be successful in your different classes without going over specific content. I highly recommend you try to get in touch with her and see if she can help you out, or see if you can get involved with one of her workshops. Okay. In terms of online tutoring, there are two different ways to access online tutoring. We have EagleQ and we have Smart Thinking. EagleQ, which is kind of our way that we have branded something called QLESS, QLESS, is going to connect you with a tutor in a platform called GoBoard. Okay, EagleQ is just the way to get in line. So you can download the app, or you can go online and access it. And then what happens is when you sign in, you say what class it is that you want, and we see you in the queue, and we will then open up a session in GoBoard, which is kind of this online tutoring platform where we have a Blackboard, we can share a screen, we have different resources that we can share, we can talk to each other, and we'll send you a link to join that. So you have to pay attention to your email. Okay, there's a video of how to access it here, and then also a link to actually get to it. Okay, so it's its location is closed right now, but it's going to be open as soon as we get back into classes. And I'm going to try to email out a link to all y'all through email as well. Okay. There are multiple different ways to get to EagleQ. This is just one of like 5 different ways, and I want to show you. The other thing down here is Smart Thinking. So Smart Thinking is good for, there's a couple things that Smart Thinking is good for. It's really good for writing. So the writing people really like Smart Thinking because you have the ability to drop off a paper, and then they can take a look at it, and within 24 hours they can give you feedback and send it back to you, and you don't have to have this live session. Okay, you can technically do it with lab reports as well. It's just there can be a little bit of an issue with access. People get confused about how to access the TCC tutors sometimes. Okay, so you have to make sure that you actually get connected with a TCC tutor. For math and science, I generally recommend EagleQ. You're going to physically be able to interact with a tutor live, and then y'all can work out sending things like through email if you want, or working on things on the Blackboard at the time. But EagleQ at least gets you connected with somebody live, and y'all can work from there. Smart Thinking, it's also good for after hours, because let me finally get off this web page. You can get outside tutoring outside of our normal operating hours. There's like 6 hours of Smart Thinking tutoring that comes with your tuition, and you can use it outside of our regular hours to get access to a non-TCC tutor. During regular hours, you can access a TCC tutor. I'd say for communications, I would recommend it, but for math and science, I would stick with EagleQ and QLESS. Okay. Another thing that we have available is our Google site that our Success Specialist put together. It's kind of our temporary Learning Commons online. You can see you can check in with Eagle Q. This gets you directly to Eagle Q this way. You can get to Smart Thinking this way. We have a list of the different subjects, and then she has some resources on different study skills, time management, different workshops that are being offered. Okay. I already shared with you the virtual Learning Commons space, the PDF of how to access Eagle Q, and then the video. You saw that on the website, but I'm also going to try to send out some information on this. And then Smart Thinking, same thing from the website, video link with instructions about how to access it. Have workshops and reviews, like the exam reviews, which I'm going to do them through Zoom. Might record some of them through VidGrid. I can't speak to what some of the other learning specialists here are going to use in terms of platforms, but that's what I like to use. Is I like to use Zoom, and then I record it using both Zoom and VidGrid at the same time, just to make sure that if I've had issues with Zoom recording properly, and so VidGrid has picked up the slack, and then sometimes VidGrid has gotten screwed up, and so then Zoom, I have the Zoom record, and that didn't get screwed up. So it really helps to maximize the chances of good record. Okay, I will try to communicate with you via email. The thing is I have to wait until I know when exams are to schedule them. So sometimes that might be 2 or 3 days before an exam review. I try to have the exam reviews at least a couple of days before an exam. But just, be patient with me. I want to try to schedule these as much as possible. Sorry, I don't know if you can hear this, but my email is going kind of nuts. Okay. Alright. So, I'll send out those links as soon as I know when I'm scheduling something. As soon as I'm scheduling an exam review. And if y'all can try to get in touch with me and let me know as soon as you know when an exam is, then I can try to get exam reviews set up. Okay? So that helps me out a lot if you communicate with me, just in case your teachers don't update me on when the exams are, because to them it's not as big of a deal, but to you, being able to have an exam review is something nice. Not to say that your teachers don't care. I'm just saying that there's a slightly different incentive. Okay? Your teachers definitely care. They want you to succeed. Okay? And a lot of them are going to encourage you to come and take advantage of the resources at the Learning Commons. We have different social media platforms that we are on. We're on Facebook, Instagram, Pinterest, and Twitter. I'm just kidding. So I don't manage any of these, but some of the other staff do, and so you can always get on these, look at updates, hear what's going on. The best thing is always just to talk to somebody personally. Such as myself. Here's a very grainy picture, but you already saw me in the beginning without my haircut. This is a haircut right here. And I'm the science learning specialist. I want to help you out. I want you to come in to our physical space, to our virtual space. The more the merrier. This is what we do. This is what we're here for, is to help you out. Okay? So I've given you my email here. I've given you my phone number to my office. Email is always going to be the best way to get in touch with me, but you can still give me a phone call. I'm in and out of the office sometimes, and then if you're trying to contact me after hours, maybe I'm doing a tutoring session at that time, but with an email, I could even respond to that while I'm doing something else. Okay, so that's what I always encourage is email. I don't want to tell you to not try to contact me via phone. If you've got generic questions, then you can call the reception desk at this number here, 201-8251. The number used to be the number that was on this slide, used to be the number to our director's office, which, he'll help you out. He's super helpful and nice, but he's, really busy, and he's not the reception desk, okay? So there's also the email, which is managed by the receptionists and some of the specialists, and so they can always get back to you with information. But I've given you my personal information. If you have some questions science related, or you're trying to figure out how to get in touch with us, please get in touch. Okay, I am happy to assist you. Alright, now for the content. Alright, so there are a couple different things that I could cover that are important to cover for Chem 1045 kind of early in the semester to get a feel for. Alright, there is memorizing different units, something called significant figures, understanding state changes between physical and chemical states, and then what I'm going to look at, which is unit conversions. Okay, pretty much all of these are things that you're going to need to know for the entire semester. A lot of things in chemistry kind of build up on each other, but this is something that I've seen a lot of people get tripped up on. Okay. Oh, and actually the other thing is calculator skills, like remembering order of operations, that whole PEMDAS, PEMDAS, the parentheses, exponents, multiplication, division, addition, subtraction, and remembering how to put things into a calculator, because you might conceptually know how to do something, but then you put it into the calculator improperly, and you get a number that's off. Okay, but what I want to focus on is unit conversions. This is very important the entire semester, and honestly, you're going to build on this as you go. So, just with repetition, the earlier you see it, the earlier you start trying to do it, the better. And it'll hopefully make the semester go a lot more smoothly. It'll make you enjoy the class a lot more than just hating it and feeling like you want to get through it, because chemistry can be fun, but the thing is you got to get through some of those initial barriers of understanding. Okay, so physical quantity is going to include number and a unit. Okay, so numbers like 12. Unit would be liters or grams or feet, inches, so on. Okay, so a unit conversion. We know that 1 foot equals 12 inches, right? So 1 foot over 12 inches is equal to 1. "12 inches over 1 foot is also equal to 1. Okay, so you can flip the denominator and the numerator, and they both equal 1. This is going to be important because when we're doing conversions between different units, we're going to often have two different choices for the conversion factor. Do we want feet on top and inches, or inches on the top, foot on the bottom? Okay, so let's do a problem together. Okay, we're trying to see how many inches are in 3 feet. Okay, that would be, if there was a problem that was worded here, it would be how many inches are in 3 feet. Okay, so we have 3 feet. That's our known. What we're trying to figure out is the number of inches. So we need to cancel out the units. We chose to use the conversion factor, that's what these are called, of 12 inches over 1 foot instead of 1 foot over 12 inches. Alright, so the reason for this, think about this, if we had 1 foot over 12 inches, you need to have a consideration for the units. It would end up being feet times feet, so it would be feet squared over inches, okay, and it would be like 3 over 12, and it's just a nonsense unit, okay, and so when we get rid of the feet, we're only left with inches, 36 inches, okay, so Let's do a problem together. I'm going to give you the equality here of 1 meter equals 100 centimeters, or 0.01 meters equals 1 centimeter. This is something that people often get confused with. They, well, not specifically with this, but which is which. Like, is it 100 meters equals 1 centimeter, or is it 100 centimeters equals 1 meter? Okay? And so, honestly, you got to get these down. This is a memorization thing. I'm trying to go over something that's a little more conceptual, but this is going to be understanding some of these prefixes is going to be important. So, not using Zoom, but I think I can still annotate. I know I can use the that there, but I'm trying to find something where I can type. That's okay. Just my handwriting's kind of messy. Okay, so you might have to memorize prefixes like centi, which is what we're looking at here, or kilo. Okay, K-I-L-O. Or what would be another one, like deci, milli, M-I-L-L-I. And so you're going to have to memorize a lot of these. This is going to be a memorization thing. We do have resources for this through the Learning Commons. So, you know, touch base with us. Your teacher is going to go over this. Always talk to them about anything that I'm going over. Visit them during office hours. That should always be your first line of defense. But I'm available. The other tutors are available. We're all here. We really want to make sure that you succeed. Honestly, we really want to see success rates. Okay, we want to see you succeed. We just, you know, we need to work together to make sure that that happens. Okay, so I'm just giving you examples of different conversion factors. I'm getting a little off track here. All right, there we go. I was going to say, how do I get rid of this thing? And I do want to erase it. Erase all ink. Okay, so our two possible conversion factors that we're working with, hopefully you can follow this, is that 1 meter is equivalent to 100 centimeters, or 100 centimeters is equivalent to 1 meter. So these are going to be our two possible conversion factors. I want you to take a second, think about which conversion factor do you think you need to use here? The 1 meter over 100 centimeters, or 100 centimeters over 1 meter? Okay? I'm going to give you a little clue here because it's the first problem we're looking at. Okay, this might make it a little bit easier. We're trying to figure out centimeters. We have meters. We want to cancel out the units, the meters. So should we use the first conversion factor or the second? Think about that. Okay? So I'm going to tell you right now, it's going to be the second because we have centimeters on top, meters on the bottom. We want to cancel out the units. So pull this over, meters get canceled out, and we end up with centimeters. Alright? Hopefully that makes sense at this point. Now this one, I would really like to for you to just do this on your own. So I'm going to post a question here and have you do it on your own. Then I'm going to kind of walk through the process. Okay? I'm trying to do this as close to it being a live session and a lot of the questions that I ask as possible. Alright, so our equality and conversion factors are the same. You got to think about which conversion factor do you want to use, the first one or the second one. Okay, give you a clue. I'll pull it all the way up. But remember, what you're gonna have is you're just gonna have a problem that says how many meters is 8.72 centimeters. All the rest of this, you're gonna have to set up on your own. This might be a couple weeks into the semester. You know, a lot of your teachers like to kind of walk you into it slowly. But, you know, this boot camp, I want to show you some things that you're going to be saying, this is my opinion, is it's better to get a little anxious and worry about things before a test and then to kill it on the test than to actually be worried during the test and afterwards. Okay? So think about what conversion factor. First one or second one? It's going to be the first one. We have meters on top, centimeters on the bottom. So, remember, units must cancel. 1 meter over 100 centimeters. Cancel out the centimeters. We get the number of meters. 8.72 divided by 100. So 0.0872. This brings up, and I haven't addressed it, I'm going to mention it a couple of times. This isn't technically a lesson on significant figures, but a lot of things, they kind of all play together. It's, you know, do we talk about conversion factors before significant figures? Do you talk about significant figures before conversion factors? Because they all kind of play together. Okay? So, there are a lot of rules for this. Not a ton, but there are rules for significant figures. And your answer you always want to have in the proper number of significant figures. Okay? In this problem, it's going to be 3 significant figures because within the question, the number, the variable that we're working with that has the lowest number of significant figures, the only number we're working with, is 8.72, which has 3. Now, I'm just going to pop a couple little things in here. I'm not telling you to memorize these, but it's just so that you've at least seen them and heard them. If you put a 0 at the end of this, it becomes 4 significant figures. However, if you write something like, again, bear with my handwriting. This is, I'm not saying in reference to this, but if you write something like 80,000, that only has 1 significant figure. So this is a comma, I promise. Okay? But 0.800 has 3 significant figures. Any 0 that's after a number, after the decimal, is significant. Okay? A lot of rules. We have handouts on this. Your teacher's going to go over it. You can always ask them about it. You can come and get tutoring, help with it. You can access our resources through our website. So, you know, at least even just touch base with us or your teacher, and we can direct you in the right direction with this. But conversion factors, significant figures, you're going to see them all semester, okay? And really, it's going to have to start becoming natural sometime after the first exam. Ideally before the first exam, because you want to do well on it, okay? Hello, there we go. Okay, get rid of this. Erase all ink. Okay, so that's 3 significant figures. Something else to consider, and you'll actually see significant figures using what's called scientific notation a lot, okay? So that's when you see like 10 to the 3rd or 10 to the -5th or something like that, okay? So this right here is equivalent to, and you got to follow the dot, how many times you have to pull it over. 1, 2 times. So this is actually 8.72 times 10 to the -2. Okay? That 80,000 that I wrote earlier, I should have kept it up. So 80,000, you can write as 8 times 10 to the, let's see, 1, 2, 3, 4, 10 to the 4th, okay? And then this is equivalent to 8.72, I'm running out of space here, times 10 to the -2, okay? keep that in mind. When you're working with lumen ohm, you're not going to be able to use superscripts and subscripts to put in different formulas or numbers like this, and so you're going to end up, for something like 10 to the second, you actually have to do this caret on your keyboard. It's shift 6, okay? So it would be like 10 caret 6 for 10 to the 6th. If you wanted to do a subscript, so like say we were working with CO2, the way that you would type that into lumen ohm, and you're going to get used to this. It's a lot of little things, but it would be CO, and then there's this little underline that is it's shift, and then the key that's next to 0 on your keyboard, and then you would just write 2 like that, okay? And like H2O would be H2O like that. 10 to the negative 2 would be 10 caret negative 2, okay? And again, I'm tossing a lot of stuff out there. At minimum, get the conversion factors down, but because there's a lot of things that kind of overlap, I want to toss as much stuff in as possible. Don't get overwhelmed. I mean, this is a boot camp. I'm going over a lot of things all in a very quick period of time, okay? These are things you'll have to know at some point, but, pace yourself, get some good study habits together, and, go to office hours, come to us, the Learning Commons, both either in our physical or virtual space, and it will be all good, okay? Alright, I'm taking extra time because this is recorded, but I'll try to keep moving. So how many feet is 39.37 inches? Our equality, and again, a lot of these, you're being given these equalities, but you're going to have to, at some point, memorize these. You know that 1 foot is 12 inches, but there are going to be other equalities that you're going to have to start memorizing at different times or know how to look up. Okay, a big one is going to be molar mass. You're like, what the heck is molar mass? Honestly, don't worry about it now if you don't know, but, it's one of those words that, maybe look out for farther down the line. Applicable conversion factors, and again, you're often not going to be giving conversion factors, especially later in the semester. Early in the semester, I can't vouch for what your teacher is going to give you, but we have two different options. We have 1 foot over 12 inches, 12 inches over 1 foot, okay? We're trying to figure out how many feet are in 39.37 inches. I'm giving you a lot of this information, but at minimum, a problem, all you might see might just be how many feet is 39.37 inches, and you would have to do the rest of this on your own, okay? So, which one do you think? The first or the second conversion factor? Alright, yeah, the first one, because we have inches on the bottom, we would cancel out inches and get feet, okay? So, again, units must cancel. Pull this over, 1 foot on top, 12 inches on the bottom, should be about 3.28, okay? Now, I keep forgetting to change this, okay? And, but I at least want to mention it. Sometimes when you have something that's a little bit off, it's a good opportunity to mention that it's off and use it as a teaching point, okay? So how many feet is 39.37 inches? If you're following along with my explanation of significant figures, you realize that the answer needs to have 4 significant figures, actually, okay? So when you do this math, let me pull out my calculator, or one of them. I have like 4 calculators floating around my office here. I just can never find them when I need. So 39.37 divided by 12. So it's 3.28083333. So that would actually be 3.281, you would want to round, would be the answer with proper significant figures. okay? If you don't follow it, don't worry too much. Kind of the first step to learning something is knowing that you don't know it, identifying what you don't know and then trying to get to know it. Like at this point, okay, I need to get conversion factors down, I need to get significant figures down, and I need to understand how to put things into my calculator properly, okay? And so what you're going to do is you're going to recognize that was an issue, something that you didn't know, and you're going to make it a strength, and it's not going to be an issue, okay? All right, how many kilometers is 15,000 decimeters? This, I'm going to give you the conversion factors for this, okay? But you are very quickly in the semester going to be expected to know these conversion factors of what a kilometer is, what a decimeter is, based off the prefixes. You're going to run into like kilograms, run into maybe decigrams or milligrams. So it's not just, we're looking at units of length here, but we're going to see a lot of units of mass. Or you might see milliliters or deciliters or kiloliters, okay? And so there's different units, and you need to recognize this prefix, okay? Again, I'm going to give it to you here, but you will very quickly need to memorize these. So what's the first one? Decimeter. That's what we have. So how does a decimeter relate to a meter? Kind of meters or grams or liters, they're kind of our standard. They're what we look at as kind of the base unit because it doesn't have that prefix. So there are 10 decimeters per 1 meter, okay? And there is, I'm going to kind of just go along. So, whoa, no, that's actually not what I wanted to do. There are 1,000 meters in 1 kilometer, okay? And when you memorize these, you need to remember that it's 1,000 meters in 1 kilometer, not 1,000 kilometers in 1 meter, okay? There are 1,000 millimeters in 1 meter. And I am doing a little bit of overkill here because this is recorded, so I have that privilege, okay? But actually, if we were to compare millimeters and kilometers, because there's 1,000 millimeters in 1 meter and 1,000 meters in a kilometer, that means it would be 1,000 times 1,000. Or 1,000,000 millimeters per 1 kilometer, okay? That, you can write it with all the zeros, or you could actually write it as either just 10 to the 6th or 1 times 10 to the 6th, okay? So it ends up having 3 zeros. Write it out, you'll see. You know what, I'll do it for you. 1, 2, 3, 1, 2, 3. So technically there's decimal right here. We got 1, 2, 3, 4, 5, 6. So 1 times 10 to the 6th. Okay. Alright, again, I digress very easily, but this is all important information. The only two things that are really of importance are these first two. Okay, so get rid of the eraser. We have x kilometers times 15,000 decimeters. So what's going to be our first conversion factor right here? Okay, so we want to convert from decimeters to meters. So we're going to want to use this, but are we going to have decimeters on the top or on the bottom? We're going to have decimeters on the bottom. We're trying to cancel out units, so it's going to be 1 meter over 10 decimeters. Now there's two different ways to approach this at this point, depending on kind of your style, but neither one of them is right or wrong. It just depends on what you feel comfortable with. One way is you could take a moment and you could actually do 15,000 divided by 10, and so you would have 1,500 meters at this point because you canceled these out, okay? And then we could go ahead and do a conversion factor with 1,500 meters at this point, okay? I'm going to erase this. I'm going to get this out of the way, get this out of the way. I'm going to hold on to this right here, okay? So that's one way, and then you can do your conversion factor here. Another thing is just to put all the conversion factors next to each other. So we got rid of the decimeters, put another conversion factor. Think about what's my next conversion factor going to be, okay? Now we know it's going to be this, all right? So we have meters on top, we have meters on the bottom. So we have 1,000 meters on the bottom, 1 kilometer up top, okay? And so then we can just kind of do what some people might call this train tracks method, where we go through the whole thing and we're getting rid of units along the way. We end up with 1.5 kilometers, okay? The alternative that I was offering is you take a break at this point, you actually write it out, and then do the next step kind of independently, where you write 1 kilometer over 1,000 meters. You're going to get the same answer. It's just, it's a different type of systematic. Okay, and so you get rid of the meters, and end up with 1.5 kilometers. Okay, same difference. It's just depending on how your mind works, whichever way works for you. I wanted to present both. Okay, so let me get rid of all the ink on here and move along. Alright, so this next one is a 3-stepper. I'm going to give you a little clue on that one, so try to figure that out. Alright, so first conversion factor that we're going to use. We have days. What do we know units of? We know how many hours are in a day. 24 hours per day. This is where we should start. So that cancels out days. So, maybe at this point, you've kind of thought, oh, okay, I get the idea. So what do we know about hours? We know how many minutes are in an hour. Okay, so cancel out hours, and now we have minutes. But what are we trying to get to? Seconds. Okay, so we still have one more step. What's our conversion factor? Think about it. I don't get to interact with you, so I don't get to actually ask you. But it's fine. It's just a different method. So, yeah, that's right. We have minutes on the bottom, seconds on the top, 6 seconds per minute. Boom. This is going to be a giant number because we have 4.8 times 24 times 60 times 60. Ends up being 378,432 seconds. Okay? So, it's a good chance to take a moment to consider significant figures. What do you think? How many significant figures? If you've been following along. Right. Okay. 3 significant figures. So, because we have 4.38. So how do we write that? I gave you some examples earlier. There's really going to be two different ways we can write it. We can write it as 378,000, so 000 after this, or we can write it as 3.78 times 10 to the what? Think about that. So 1, 2, 3, 4, 5. 3.78 times 10 to the 5th. Okay? Either one is correct. You also could do 300, I know that 3 was really wacky looking, 378,000, but really you're going to be working with this a lot with scientific notation because it's a lot more compact. It's just the way that you're going to see a lot of problems written out. So really kind of familiarize yourself with how scientific notation is going to work. Okay, and some of the homeworks that you do, I'm not going to say they won't accept this, but you might end up putting it in, and it might not accept it initially, and then you have to email your teacher. So try to, if you can, work with scientific notation. Generally, though, it should, either one is correct, okay? Especially on an exam, they're both going to be correct, okay? All right, so last portion of the boot camp here. Simple math with conversion factors. Now this is going to be a little bit different. We're looking at something slightly different here. All right, so for this one, I want y'all to try to work this out real quick, and then I'm going to kind of show you what I'm looking for. And you'll see, I'm not, I guess technically I'm trying to trick you, but there is something key here that I think you're going to miss, and that's the point for this problem and the next couple of problems. So we're trying to get the area of a rectangle. So pretty basic geometry. I'll just give you the formula. Area equals length times width. Alright, so you should have gotten something like, I think it's, well, I don't have my calculator right in front of me, but I think it's like 41.2. So 41.2, but then the key here is, what are the units? Okay, and it's not centimeters. It's centimeters squared, okay? We have centimeters times centimeters squared, okay? So this is key. You gotta pay attention to your units. That's the point of this. All right, so this next one, I want you to convert 41.2 centimeters squared to meters squared. All right, so you might be tempted to do the conversion factor of 1 meter over 100 centimeters. Okay, now you're partially correct. But remember, the point of this is we're trying to look at units. This is wrong right here. 41.2 centimeters squared times 1 meter over 100 centimeters would equal 0.412 centimeters times meters. You see, because it's centimeters squared times meter divided by centimeters, you would end up knocking out one of those centimeters, but not the other. Okay? So, a better way to approach this, and very similar way to approach it, honestly, it's just we're missing one step, is to do that initial conversion factor. Cancel out the centimeters, and so it might help you to see, like, centimeters times centimeters, instead of having it centimeters squared like that, just to keep track of the units. And then we do it again. We knock out those centimeters. And so we end up with 1 meter times 1 meter, which is 1 meter squared, times 41.2 divided by 100, and then divide by 100 again, so divided by 10,000. So that's like divided by 10, divided by 100. Hold on. I might be. Oh, because it's 41.2. Yeah, instead of 4.12. So this is correct. Yeah. So 1, 2, 3. So 4.12 times 10 to the negative third. Okay. Or 0.00412. But there's 3 significant figures. Be aware of that. Okay, so technically, if you want to, you can do it this way, but we've broken down what that means right here. Okay? 1 meter times 1 meter of 100 centimeters times 100 centimeters. So 100 times 100 is 10,000. So the actual relationship here is 1 square meter is equivalent to 10 0 0 0. Oh, that 0 got out of control. I don't want to clear all. Can I just clear? Oh, yeah, undo. Okay. 10,000 centimeters squared. Okay. This is, I mean, conceptually you're seeing it right now, but you might be tempted to think, if someone were to ask you how many square centimeters are there in a square meter, to say 100. Remember, there's 100 centimeters per meter, but there are 10,000 square centimeters per 1 square meter. Okay? So this next one, you got to kind of remember or know the relationship between centimeters and millimeters. Okay? I'll write it out for you here. So, if you recall, 100 centimeters equals 1 meter. Okay? And then 1,000 millimeters equals a meter. Okay? So, this means that 100 centimeters also equals 1,000 millimeters. So we can set a conversion factor, or we have 2 different conversion factors based on flipping them, of 1 centimeter per 10 millimeters, or vice versa. Okay? Because 1,000 divided by 100 is 10. Okay? So we can see, right, okay, so we want to remember that 41.2 centimeters squared is 41.2 centimeters times centimeters. Okay, so we're trying to figure out millimeters squared. I gave you the conversion factors. So you're not going to be given conversion factors a lot of times. You're just going to have to honestly make your own. And so we cancel out the centimeters. So this is the kind of the flipped version. Numerator and denominator are flipped. Getting rid of centimeters, then we do the same thing. Okay? So we end up with 4,120 square millimeters is equivalent to 41.2 square centimeters. So that is a difference of 100. Okay? You can see 10 times 10. Okay? Whereas if we were just working with linear units, they would only differ by a power of 10, but instead they differ by 1,000. Okay? So again, same thing as saying 10 squared or 100 millimeters per 1 centimeter. per square centimeter. Now volume, you kind of got the idea here. Take a second to do it. Length times width times height. So 15.2 times 3.7 times 8.6, 480 what? And I know y'all got it down by now. Centimeters. Whoops. Times centimeters times centimeters. Cubic centimeters. Okay. We want to convert that to cubic meters. We have 480. It's the same as centimeters times centimeters times centimeters. So it's the same story as when we were working with square units. This time we do the conversion factors 3 times to get rid of the centimeters. So it ends up being 480 divided by 100 divided by 100 divided by 100. 100 times 100 times 100 is, so 100 times 100 is 10,000. Then 10,000 times 100 is 1,000,000. Okay, so that actually is the difference between a cubic meter and a cubic centimeter. It's a difference of 1,000,000, or 10 to the 6th. It's kind of wild, huh? So 480. Oh, right, just breaking that down. So it'd be the same as saying 1 cubic meter over 1,000,000 centimeters. Okay, and so the answer ends up being, you can do 0.000480, but this is always going to be preferable to try to use scientific notation. So 1, 2, 3, 4. 4.8 times 10 to the negative 4. Okay, so yeah, that's breaking that down. This is 1,000,000 right there. 4.8 times 10 to the negative 4. Okay. Another way to do it is to initially convert these into meters. This, honestly, this is more of the way that I do it. It's whatever works for you, and you don't get confused. It's very, very easy to just make a mistake with one step in chemistry, and then to kind of doubt yourself and get frustrated and whatever. Okay, but you know, it's with repetition. You'll get better with it. And honestly, everybody's struggling with this. Okay, it's just matter of repetition. The more you do it, then you become the star. All right, you got it. So volume, you can end up doing just 0.152 times 0.037 times 0.086. You don't got to go through that whole process before you end up with the same number. Honestly, if this is how I would do it, is I would do all those conversions initially and then multiply like that. Okay, but everybody has their preference. Okay. So, by what factor do millimeters and centimeters differ? Okay, remember it was a power of 10. And so this can also be, say, by what factor do centimeters and meters differ? Okay, so 1 centimeter equals 10 millimeters, or 1 meter equals 10 centimeters. So when we're talking about linear units, it's a difference of 10. When we're talking about square units, though, it's 10 squared, 10 to the second, so it's a difference of 100. Okay? When we talk about cubic units cubed, it's a difference of 1,000. Okay, now the difference, this is between things that initially are by a power of 10, but like if we were looking at centimeters to meters, or if I were to put, here, just so you can follow my line of thinking, okay, I would say 100 centimeters per 1 meter, and then 1 square meter would differ from square centimeters by a difference of, I don't even have space for that here. difference of 10,000 because that's 100 squared. And then at this point, with the cubic meters versus cubic centimeters, it wouldn't be 1,000, it would end up being 1 million. Okay? So try to understand the concepts of this. When you try to just memorize things and you think, okay, you know, cubic is, like if you try to say something to yourself like cubic is 1,000. What does that mean? Cubic is 1,000. You got to understand the base unit. It's a lot of chemistry. You don't got to memorize things, but you need to understand the concepts, and you need to be able to kind of derive formulas and figure things out on your own. Okay? So if that's not familiar to you now, try to get familiar with it. We can work with you on that. Your teachers can work with you on that, and so on. Okay? So that's it. I'm posting the feedback form right after this, and links to another resource. So go ahead and fill that out for me. That would be wonderful. And that's the end of the boot camp. I hope it was helpful.